Okay, hello everyone. I'm Xiao Gang. Okay, in the last lesson, we created a basic UEC pressure class. Okay, in this lesson, we will continue to look at some of these basic things. Okay, so first of all, we have already created a UEC pressure class. Next, everyone needs to create several basic types of structures and interfaces in sequence. Okay, so how do we do it? It's actually very simple. I'll do it together with everyone here. We create an actor here, right? If we are creating an interface, we can do it like this. Okay, we opened it again, and we haven't changed the map here. According to what you said, we still need to change it. Let's not use word preparation here. We use an empty level. Then we save amendment here and put it here. Just put it under our content directory. We specify it in this engine. Okay, so what do we do next? We do the same thing. We go to Tools. We keep a C++ class, and this place is very convenient. In the common class, there is an Unreal interface. So this is our interface. How do you create it? Just click Next directly. Then we put it into our... Let me think about how to name it. Then put it in the base folder. Put it in this folder. Let's call it XG. XG base interface. Okay, no problem. That's the name. Okay. So this interface is created, but let's not compile it for now. We still need to create others. This is a simple interface format and definition. Okay, then let's create the next one. We'll create a blueprint one. 静态函数库. That's it. What is it? You should have used this in Blueprint. Blueprint function library. Right? That's it. We need to create a cplow plus trr plus version. Okay, let's delete it. Here, we'll leave a class. Let's find it. Here, okay. So how do we do it actually? Let's just call it xt. Bus. Then, I like to call it 来谱. It's basically a reference for Blueprint. As for the location, we'll put it in the base. Okay, so let's create it. Okay, that should be fine. At this point, let's not overwrite it yet. Let's just leave it here for now. Finally, we'll create a plugin. Why create a plugin? Because there is a part of this thing I want you to take a look at. I need to create a plugin. Let's create one. After this part, editor plugin, create a new plugin. We select Blueprintable. Let's call it XG. Let's name this project sample. Let's call it sample. It's just a casual plugin. We'll just give it the name. We better check the test option. Okay, let's create it. We need to wait here for a moment. Creating the plugin may require compilation. This plugin, this module, because it is creating a new module, so the plugin, this module, it may have some binary files and intermediate files that need to be dynamically generated. So it will be a bit slower. Okay, then this time we can go ahead and handle it. Okay, let's close it. It didn't prompt us to reload, right? We need to manually reload it. Before we reload, let's create our struct and enum again. This makes it easier to operate. We'll call this Xiao Gang, base as truct. This is a struct. It's p. Okay, next we'll create the struct, and then we'll create an enum. A little tip, you can use F2 to rename easily or double-click, so you don't have to right-click and select it. Okay, after creating it yourself, we go to the project and then go to this location. Refresh it. Okay. Good, let's make it single here. Then let's try to compile it. See if it reports an error this time. Okay, no problem, right? Might be a bit off. We erase it, and reopen it. See if it can be recognized smoothly. This Unreal C++ syntax. After we erase it, it should be recognizable. Okay, no problem. This is a standard interface for us. We haven't used interfaces much yet. Later, when we use advanced features or in the project, we'll show you again common methods of interfaces. And this is a BP library. Remember, look at this BP library here. It looks like this. It's the same. It's just inheriting this. This one has an extra. This function, this core space method. Then it prompts you, all methods in here should be static. It inherits from upwards, and we usually inherit from it. But sometimes, to allow our plugin to be used in a standalone program, we won't have it inherit from blueprint function library. We'll have it inherit from obuwaj, so this doesn't have much impact. This is the library. You can see this place. Okay, so didn't I just create a plugin earlier? Then look at the structure of this plugin. This is its icon. Double click to see it. Let's erase it. And similarly, under source, there are Pugly and Pugly, and this is the name of the module. This was explained in detail to everyone before. Very, very detailed. And as for this place, let's directly look at this BP library. Okay, pay attention and observe. Here it uses Genity's UCLASS body. But then, so it declares a constructor here. And we will talk about the constructor later. In UE5, your OGOpter can only have 2 constructors. It does not support passing parameters in the constructor. So we will talk about how to handle this issue. Actually, handling it is very simple. We just need to do 2-stage initialization. Just put the content we want to initialize into begin play, then do the 2nd stage construction. This is the academic term for it, and it explains it here. That is, this is called a function library class. That is a function dependency library. Every function should be static, and this blueprint node can be called and used in any blueprint. When declaring this function, you need to define some metadata. This is our metadata. Okay, then this keyword, it will be this K keyword, this Bluetooth port and blue takeable. They will make this blueprint. In the blueprint, it is a blue node or a green node. A blue node is one with execution pins. The blue node is called co-able, and the one without execution pins for getting data. And this one has no execution pins. So that is to say, but you need to know, boot to pair. It executes once every time it is called. Remember this sentence. Because many beginners make this mistake, he wrote logic inside boot to pair. He said, why is it that I only skipped 2 nodes? The boot to pair values I called twice are different. Because the values inside your boot to pair are meant to be modified, so they end up being different. And if you use this blue one, it only gets called once. Then the result it returns can be temporarily stored in that place. Next time you can just pull it directly from that instrument. That's what it means. You need to understand this sentence well. Okay, this is the display name, and this is a keyword, some categories. This is a simple calculation, auxiliary thing. Good. Finished looking at these. So what do we do next? Next, let's define our structs and enums. Let's see. We'll still follow our most common practice. I won't write the copyright notice here. Too troublesome. It would waste everyone's time. But we still follow the standard writing style. We write a struct. First, this is compiled only once. Then include our minimal core dependencies. At this point, because we know this file has reflection, we must include this reflection. The fixed format for this reflection is rail name plus generated dot. And at the same time, this is a struct, so we need to write the struct macro first. This is a struct with reflection, and it is a struct. We call it f small base struct. Okay. Then we also add the macro generated USTRUCT bed. Good. Let me check if there's any spelling mistake. Take a look to see if there's any spelling mistake. This is easy to misspell if you spell it directly. Okay, let's take a look. Let's take this red, dip it so we don't write it wrong. Indeed, there's a mistake somewhere. There's city RU city, should be fine. Then here we include its header file. This is its source file. Let's include the header file. Okay. Let's take a look now. Let's switch back with 80 plus O. It has already recognized it. No problem at all. Good. Let's practice writing in Enum. Let's write another Enum. Same as before. How do we write this Enum? Same as before. Let's write this code first. Then include the minimal dependencies. Then this Enum. It generates directly here. No problem. Okay, pay attention. If you want to reflect it to blueprint, you need to make it write a UINTEFACE after it. Otherwise, it won't be reflected to blueprint. Let's write something simple. Let's write alone. Let's write alone, then bumx. And I remember, because this one has reflection information, so we need to include the header file here at the beginning. These things might need to be repeated over and over. Okay. Similarly, let's switch to its source file to include its header file. Okay, let's include it here. Let's compile it now. No problem at all. It has also been recognized. So, can we use it in Blueprint now? Unfortunately, I have to tell you that we cannot use it in Blueprint yet. We can start it. The reason it cannot be used is something you can think about. Why can't it be used in Blueprint yet? Okay, good. Let's take a look inside the Blueprint here. Then we need to create a new variable, and then you type xt here. You will find that it only has x to best actor, but in fact, we have created many things. You will find it only has this best actor. Only it. Then you will find this best object, and this base struct. And these enums are all missing. So what do? Actually, if you observe carefully, why does this base actor exist? Because it inherits from actor. In Eckhart, these are wrapped in red, right? So what should we do? Let me verify it for you again. Is this the cause? We often use this called the construct node, right? You might use it less often. You usually prefer to use this new object, maybe. There is stint. Yes, that's right. Then this book xj, okay, you see this new object, and then you will find you cannot promote it to a variable. This place is quite interesting, okay? Let's handle it simply now. Alright. So if we do it this way, this is just a simple example. I want to make it easy for everyone to understand quickly. Okay, let's make it so he doesn't have to write it. Since it works, we mainly write it like this in a while object. Object, okay? He writes it then in our enumeration, then in our struct, but there is no data in our struct yet. And our default access specifier is actually public, but I personally prefer to write it out explicitly. Default access permission of the struct. So here we give it an fstream. This way you can see it. We call it straight-lem. Then we let it initialize. This declares a variable as fstream. And at the same time, we give it a default value. And we also give it reflection information. Let me see how to spell this property. Pry, that was typed wrong. Okay, we recognize that we have started now. Now take a look at this. What is inside the variable? Okay, now let's observe it. We are still observing the blueprint. It should be more intuitive inside. So at this point, we say xg here. You will find that this struct is present here. But after you take the struct, you will find that it does not have a break, right? But it should be able to make xda, right? It only has break, but it clearly has variables. Why is that? Because we need to add something to that property. At least now we can be clear here. Reflect these things we wrote into blueprint, right? Then create a variable to use it. That's the point. And there's no such issue. Actually, strictly speaking, this should be called PTA. To a paper lantern. That's correct. Okay. So that's it then? Okay. We still have a small issue. We'll leave it to be solved later. Because for now, we're just laying the groundwork for everyone. So in this lesson, we will mainly give everyone simply implemented this object, this interface and this struct, and this enum. So we mainly want to think about these mainly emphasize UCLASS macro, because the UCLASS macro, interviewers especially like to ask you about macros sometimes. They will ask you what is the difference between this macro and generated body. And you need to know that if you use this macro, you must declare such a constructor in its CPP file. Otherwise, it will cause a compilation error. Okay, so we will stop here for this lesson. Let's check if there is anything missing. Let us introduce the UEC pressure class. At the end, we see these red ones. They will control our property variables, enums, or methods, their behavior in blueprint. So actually, did we create a plugin? Our plugin should have... I clicked the wrong thing here. Sorry, never mind. We have a plug car here. This plug is named this, right? It is called xsample function. It is a static method. It is placed in our blueprint function library. Let's see if we can reference this method. Let's find it. Exec, not him. Wrong. Exec. Take a look. Find him xg simple tool testing. This is cat graph. Got it. Right. Cat graph. Actually, you can also stack a layer on it. Just use stacked layers to write the bookline. Okay, you can see it's just such a U function. Okay, in this lesson, we will basically let you try it out simply. We will write the complex logic later. Let's take a look at the diagram. This diagram actually corresponds to what is in our project. You see, if a t, a y, et a, it has U prop, U function. You see, it is a U class. It contains U function, right? And this is the relationship between function and U property. Actually, class and struct in traditional C++, there is no difference except their default access permissions are different because a class defaults to private access, a struct defaults to public access, and in UE5. U classes and F classes, they represent completely different things. Their entire architecture and functionality and implementation approaches are all different. Our U classes are mainly for implementing functional business logic and the underlying framework, while F classes are often only used for organizing properties and manipulating data. So similarly, F classes, it cannot use U-style methods. Then, if you need to call such U-style methods in Blueprint, you need to perform some special operations because you will find that in Blueprint, you rarely see this struct. And here, I will list a special struct for you. This struct will be discussed in detail later. This struct, right, actually has no methods inside it. These methods need to be written separately to exist. Generally, if you don't write them yourself for a struct, it does not support U functions. That's roughly what it means. Okay, this is an official document. Now we have basically covered all the basic concepts of UEC++ for you. Then next, we will go through one by one the mistakes you are prone to make. We will expand on the knowledge points you need to pay attention to. Actually, up to this point, it should be about enough. That is to say, if you find the following parts a bit difficult to follow, then you can just take some notes and know that these things exist. Then, you can directly move on to the later parts about basic data types, talking about F-stream flam or time-related content, or engineering cases, or official examples. At those points, you need to listen carefully. For the next few chapters, we will, for these next few chapters, mainly mention some in-depth content from the official documentation. Good, alright? Then we will stop here for this lesson. Thank you all.